Students and friends, welcome to my YouTube channel. Today I am going to solve hollow cylindrical problem, heat and mass transfer. So what is the problems given here? A insulated steel pipe carrying a hot liquid of inner diameter, So first when the diagram will be there. So liquid they given, inner diameter. And its diameter will be 25 centimeters. So what is the R1? So we'll write here dimensions also. R1 will be 12.5 centimeters. So 0.125 meter. So what is R1? 0.125 meter. Then what is R2? Read this question again. Carrying the hot liquid, inner diameter is 0.25. Wall thickness is 2 centimeter. Now we'll give the wall thickness here. Wall thickness is there. So this little diagram is not much required, but okay, some extent. So this is given 2 centimeter. 2 centimeter. So R2 is equal to 0.125 plus 0.02. 125 plus 0.02. It is coming 0.145 meter. So R2, R1 we know. Thickness of the insulation is, now give the insulation. So we'll give the insulation. Insulations will be, I am giving different color. This is called insulation. This thickness they given how much? 5 centimeter. Insulation thickness is 5 centimeter. So that means this is the R1, this is the R2, this is the R3. So R1, R2, R3. So what is R3 here? 0.145 plus 5 centimeter 0.05. 0.05. How much it is coming? 0.195 meter. So you know the R1, you know the R2, you know the R3. So over. Now temperature, the inside surface temperature coefficient. So now see here, then H1 they given. That means HA. Suppose inside we are taking here HA, TA. How much HA? 730 watt meter square Kelvin. Then HB outside, HB and TB temperature, outside temperature. HB will be given 12 watt meter square Kelvin. So heat transfer coefficient unit is watt meter square Kelvin. Then K they given, K is still they given, K1. K still means okay, K still and K insulation they given. So this is one, this is the K1, this is the K1 and this is the K2. So K1 they given how much? 55. Steel means 55 watt meter Kelvin. K insulation they given 0.022 watt meter Kelvin. Actually if is metal will be there na, this thermal conductivity will be big value. If any insulations like na value C more or less than 1 only. What they are asking? Heat loss per meter length of the pipe. Only they are asking only heat loss per meter length only. They calculate that only they are asking. So here if they given heat transfer coefficient, that means this problem is known as convective and conductive. Conductions, convections both will be there. So HA, HB. What is HA, HB? Inside and outside convection and then conduction. So what will be the now heat flow rate formula? I will write now. Heat flow rate formula what is? Q by L. L the given per meter length. So directly we will write Q by L. Only one formula will solve the questions. What is overall temperature? What is overall temperature? TA minus TB. What is temperature? TA minus TB. So this temperature they given liquid and surrounding. That means this is 273. This is 20 degrees Celsius. If Kelvin means how much coming temperature? 293. 293 Kelvin. What is TA? 100. So 373 Kelvin. So TA minus TB you know. Now what is the thermal resistance? For convective thermal resistance what will write? 1 by HA R1 divide by 2 pi, divide by what we are writing. So see here ln R2 by R1 is equal to 2 pi k L. Suppose L not there, na L. So for this here, L will be taken here. So 2 pi k. So what will do now? 2 pi k you write here itself. Then this is the thermal resistance for first block. Then this first is convection. Then other is conduction. So write ln R2 by R1 divided by ln R2 by R1 divided by thermal conductance K. So already K there we wrote there now. HAR1 K 2 pi, you keep here 2 pi only because 2 pi RL. So here write K1 plus ln R3 by R2 by R3 by R2 by K2 plus 1 by HB R3 HB/R3. So this is the our formula for this. So total thermal resistance, overall temperature, you can write here 2 pi also, here 2 pi, here 2 pi k, L already is there. So common is there, that's why we wrote here this separate one, 2 conductive, 2 convective. Substitute all the value here. 2 pi TA how much? 373 minus 293 divided by 1 by HA they given 730 into R1 0.125 plus ln R2 145 divided by R1 0.125 divided by K1 55 plus ln R3 0.195 divided by R2 how much? 0.145 divided by K is insulation 0.22 plus convective 1 by H12 into R3 will be 0.195. This is the value for this. Once you are substituting this will get Q by L. So what is Q by L? Answer you will get, so already we calculated 281.178 watt per meter. So check it one more time value. This is HA value 730 plus 0.125, then 55, this ratio is 0.1425, then 0.195 by 145. So now look here, previous problem, they not given the heat transfer coefficient. So only conductive we calculated 3 layers, now 3 times we added. Now here they given convection also. So what is the thermal resistance for convections? This conduction, convections. Just substitute value, get the answer. So this way if you will solve the questions, you will understand the better way. So before going the problem area, I given in the YouTube, I given the formula analysis and how to write the formula, that I given. Now I am the solving problem. So before almost 6 to 7 video I uploaded, what you have to do, you start from the beginning. If any one video you will learn, if you will see, you cannot understand. So beginning onwards, what way 1, 2, 3, 4 like serial numbers I am uploading, that way only you just go and full video watch from till to beginning to end you have to watch, then only you will understand. Okay students, thank you. Watch the video and subscribe the channel.